intlx Solutions, founded by engineers valued for our expertise.
We are all familiar with the Avaya Session Manager traceSM tool, which allows us to capture live SIP dialog. This is a great tool for capturing live traffic, but when troubleshooting issues that cannot be replicated, the traceSM tool should not be used. This is because leaving the traceSM tool running can cause performance issues, and when running in live mode, the traceSM tool buffers out at 10,000 packets. For issues that require long-term troubleshooting, we instead use the siptrace command. Issuing the siptrace command followed by a question mark shows the various options available to the command, including status, start, stop, and logs to manage the size and quantity of captured data. Let's begin with the siptrace status command. The command provides a host of useful data, including whether the trace is enabled. A value of 0 indicates the trace is not enabled. A value of 1 indicates the trace is enabled. We can also see how much disk space is available to us for logging and our current log size and rotation parameters. Most importantly, the siptrace status command shows us where our SIP traces will be stored. Here we can see that the SIP traces will be stored in the var, log, avaya, sip_trace directory. When faced with complex issues that are difficult to replicate, increasing the scope of logging can significantly improve our troubleshooting capabilities. By expanding the log capacity, we can capture SIP traffic over extended periods without losing valuable data. The siptrace command offers flexibility in adjusting log parameters. Using the help option, we can see that the command can be modified as follows. In this example, 200 represents the number of log files and 20M denotes the size of each file. This configuration would allow for the capture of up to 4 GB of SIP traffic. It's important to adjust these parameters according to your specific troubleshooting scenario. Consider factors such as the duration of the issue, volume of SIP traffic in your environment, and available storage capacity. In this next example, we'll increase the size and quantity of logs that the siptrace tool will collect. Using the command siptrace logs, then using 500 for the amount of logs we'll capture before the first is overwritten, and 10 for the size in megabytes each file will provide approximately 5 GB of captured and stored data. After defining the trace log parameters, we are presented with status information, including the log rotation parameters we just defined. To start the siptrace, simply run siptrace start. A new siptrace status message is displayed this time with trace enabled set to 1, indicating the trace is running. The status message also shows us where the logs are being written. Let's navigate to this directory. Listing out the content of this directory, we can see that the logs are already being written. After exercising 10 minutes of test calls through the system, a total of 4 logs now exists within our siptrace log directory. The logs can be viewed utilizing the traceSM command, and you can use traceSM to open more than one log file. Here we can see about 40 calls were placed. To stop the siptrace tool, simply run siptrace stop. Upon executing the siptrace stop command, the system immediately displays the updated siptrace status. The output clearly indicates that the siptrace has been halted. This change is reflected in the trace enable status, which transitions from a value of 1, indicating an active trace, to 0, signifying that tracing has been stopped. This immediate feedback allows users to confirm that the SIP tracing function has been successfully disabled.
intlx Solutions, empowering people, connecting businesses.